So in this video, we're going to talk about transformations of the sine and cosine graphs. So before we talk about transformations, I just want to review the basic graphs of sine and cosine that we talked about in the last lesson. So it's good to be able to memorize these and to be able to sketch these basic graphs. So first of all, I'm going to look at the graph of sine of x. So recall that sine is looking at the y-coordinate of the unit circle. Now, when we look at these as functions, so thinking of putting them on an xy coordinate system, the x is going to behave like our theta, and then the y in this case is the y coordinate on the unit circle. So we're going to graph our x and y axis. And so sine, remember, starts at 0, 0. So that's an important quality to remember because the y-coordinate at theta equals 0 is 0. Then as we move around the unit circle, the y-coordinate is going to grow bigger. So then once we reach pi over 2, we reach a maximum on the y-axis. So that puts us at a y-coordinate of 1. Then after 1, the y-coordinate is going to go back down to 0 once we hit the x-axis again at a theta of pi. Then once we cross pi, we're now going to be looking at negative y values. So then we'll hit the y-axis again and be a maximum, but in the negative direction at -1 at 3 pi over 2. And let me extend my axis. And then again, we come full circle back to 2 pi. And so 2 pi is coterminal with 0. So we know we're going to have the same coordinate at 2 pi, and that is a y-coordinate of 0. So that's the basic graph of sine. And then we want to make that nice curvy sinusoidal graph. And I also like to kind of put my arrows on the end so that we know it's going to repeat. So it's just basically going to repeat that pattern forever and ever in both the left and right direction. So that's y equals sine x, which represents the y coordinate on the unit circle. So then we also have the graph of cosine. So again, we have x and y for cosine, and remember that the x is behaving like our theta on the unit circle. And this is where it gets a little confusing because y, we still have y because we're looking at the y and x axes, but y in this case is looking at the x coordinate on the unit circle. So that can be a little confusing, but remember cosine tells us that we're looking at the x coordinate on the unit circle. So at a theta of 0, the x coordinate on the unit circle is at its maximum, which is at 1. So for cosine, we're going to start at 0, 1, and then as we start moving around the unit circle, it's going to start, the x-coordinate is going to start decreasing. So once we hit that y-axis at pi over 2, the x-coordinate is at 0. We keep moving around at pi. Now that x-coordinate's on the other side of the x-axis at -1. 3 pi over 2, we're back to an x-coordinate of 0. And then at 2 pi, we're back to where we started at 1. So then again, we have that sinusoidal curve, and that is a sketch of one period for both sine and cosine. So then it's just going to repeat that same graph forever and ever in both the left and right direction. So that's our basic sine and cosine graphs. So now what we're going to be doing in this lesson is looking at transformations of sine and cosine. So in the past, in Algebra 2, you looked at transformations of graphs, and this is very similar to that. We're going to be looking at vertical and horizontal stretches and compressions. We're going to be looking at vertical and horizontal shifts. So same kind of thing that you've seen before, but how it pertains specifically to the sine and cosine graphs. So in this gray box, we have summarized all the transformations that we're going to see, and there's some new vocabulary words that go along with these transformations. So first of all, a function that has the same general shape as a sine or cosine function is known as a sinusoidal function. And the general forms of these sinusoidal functions look like this, where a, b, c, and d are all the different transformations that we're going to see. So we have sine and we have cosine. So the first thing we have is a. A tells us what's called the amplitude of the graph. And so basically it tells us how high the graph goes. So in the basic sine and cosine graph, the amplitude is 1. And so we're looking at kind of that, almost think of it like a radius on the unit circle. So that amplitude is 1 for both the sine and cosine. A way to calculate that is to just take the maximum minus the minimum value, take the absolute value of that, and then divide it by 2. So for instance, on the sine graph, the maximum is 1, the minimum is -1. So 1 minus -1, which is 2, and then half of that is 1, gives us back that amplitude. So the basic sine and cosine graph is easy, but when we get more difficult transformations, it's good to know how to calculate that. So that's called the amplitude. When we look at amplitude, we're looking at the absolute value. So sometimes when we transform graphs, we have that negative out in front with that coefficient, and what that does is reflect across the x-axis. But when we ask for amplitude, we're looking at the absolute value of that. Now next is the period. So remember, the period is how long it takes for one cycle to complete. So the period for the basic sine and cosine graphs is 2 pi. So what would affect that? That's a horizontal stretch or compression. So what you probably remember, hopefully from Algebra 2, is a horizontal stretch or compression is affected by the multiple inside the parentheses of the argument. So what I call the argument is what's inside these like brackets here inside the function. So the multiple here is what's in the b's spot. So b is affecting that horizontal stretch or compression. So remember, if it's inside those parentheses, if it's affecting the horizontal, it kind of does the opposite of what we think it would do. So if I have 2 pi as my regular period, then this b is going to be affecting the horizontal compression by a factor of dividing by b. So if my period is 2 pi, my new period would be 2 pi divided by the absolute value of that b, and that becomes the new period of the graph. Then we have this c value. Now notice this is really important, that the b value has been factored out of this expression, this argument that's that you're taking the sine of. So that's very important, especially in trig graphs, that if you have something like bx minus some multiple c times b, then you've got to factor that b out in order to see what that phase shift is. So that's very, very important, and we're going to look at some examples of that. So that c value after the b has been factored out is called our phase shift. So that's how we shift horizontally to the left or the right. And in sinusoidal functions, we specifically call that the phase shift. Then the last one is the vertical displacement of our graph, and what we call that in sinusoidal functions is the midline. So again, with both the basic graphs of sine and cosine, we see the midline is the x-axis because there is no vertical shift in those. So the midline is going to be equal to 0. And the midline and the amplitude are related. Those are both vertical transformations. So the amplitude is the vertical distance or vertical height from that midline. Now, since we call it a midline, think about it as an equation. So the horizontal equation of a line is y equals that number. So we're going to call that y equals whatever d is, and that's our vertical transformation. So that's a summary of all the transformations for sinusoidal functions, and in the next video we're going to start sketching basic transformation graphs.